Okay, let's dive in and find the area between curves. So I like to graph every single one of these, see what it looks like. First one says y equals x squared. The line y equals 0, which is the x-axis. The line x equals -1, and the line x equals 2, which I'll call over here. So we've got all shaded in green here, this region. So it's above the x-axis entirely. So I think we can just integrate x squared dx from -1 to 2. And that gives us x cubed over 3 from -1 to 2, which gives us 8/3 minus a -1/3, so 9/3 or 3. All right, second problem, I have now x squared minus 3. So we've got a quadratic shifted down by 3. So that looks like this. And then the line y equals 1 looks like this. So I'm going to have top curve, which is the line y equals 1, minus bottom curve, which is x squared minus 3, dx. And I need to know my limits of integration, which are where these two curves intersect. So that will be where 1 equals x squared minus 3, which is where x squared equals 4. So it's from -2 to 2. And you can, if you'd like, double the integral from 0 to 2. And I'm going to go ahead and combine what's in here to make my life a little easier when I integrate. So I have 1 minus a -3 is 4. So -x squared plus 4 dx. So once I integrate, I'll have 2 times -x cubed over 3, and that'll be, excuse me, I dropped off part of it there. I did not mean to. So you will have -x squared over 3 plus 4x, and that will be on the interval from 0 to 2. So I'll have 2 times -8/3 plus 8. And then when I plug in the 0, that just goes to 0. So -8/3 is -2 2/3. So 8 minus 2 2/3 is 5 1/3, or 16/3. So I have 2 times 16/3, which is C, 32/3. Number 3, excuse me. We now have y squared minus 1, which is a sideways parabola shifted to the left, or if you're looking at this sideways, down by 1. And the y-axis, which of course is right here. So we're looking at this section. So what I'll do is I will rewrite, let's see how to do this. I could do right curve minus left curve and do my limits of integration in terms of y. That might be the easiest thing to do. So the right curve will just be the line x equals 0 minus the left curve, which is y squared minus 1. It'll be dy. My limits of integration are where y squared minus 1 equals 0. So that's where y squared equals 1. So that's from -1 to 1. And I can double that integral from 0 to 1. And if I distribute this negative, I will have -y squared plus 1 dy. So now when I execute this, the integration, I get 2 times -y cubed over 3 plus y. And that'll be on the interval 0 to 1. So I will have 2 times -1/3 plus 1. And again, when I plug in y equals 0, I get out 0. So -1/3 plus 1 is 2/3. 2 times 2/3 is 4/3. So that is A. Ran out of space to do number 4, so I smartly copied this in advance. So let's work on number 4 on this slide. So I have y squared equals x, which is the sideways parabola here. And then I have the line x plus y equals 2, which is the same thing as y equals -x plus 2, which has a y-intercept up here of 2 and a slope of -1. So I think, since this is my region, I think I'm going to have to do right minus left. So that means that I actually want my curve written in terms of y. So it'll be x equals 2 minus y. This will be my right-hand curve. And then my left-hand curve will be the y squared. So I'm going to integrate right minus left. And then I need these limits of integration, which means I need to set equal to each other y squared equals 2 minus y. So that's y squared plus y minus 2 equals 0. Factors into y plus 2, y minus 1. So those two values are my limits of integration. They will be negative 2 and 1. So let me now integrate. I will get 2y minus y squared over 2 minus y cubed over 3 from negative 2 to 1, which gives me, let's see, 2 minus 1/2 minus 1/3 minus negative 2 times 2 is negative 4. Negative 2 squared is 4. Negative 4 over 2 is negative 2. Negative 2 cubed is negative 8. Made negative is positive 8/3. So I clearly need to clean this up. What can I clean up? I have, first, I'm going to come over to the left. Let's do some algebra here. So I have, I'll do this with a common denominator of 6. So I have 12/6 minus 3/6 minus 2/6. So my first one is going to be 7/6. My second section here is going to be negative 6 plus 8/3. And if I do that out of sixths, I get negative 36 over 6 plus 16 over 6, which is negative 20 over 6. Remember this negative sign, though. I'm really taking 7/6 minus a negative 26. So I end up with 27 over 6, which simplifies to 9/2, and my answer is D.